Interstellar is built around a black hole that shouldn't exist. Not according to a critic, according to Kip Thorne, the Nobel physicist who designed the film Science himself. That should have been the end of it. Well, it isn't. Because the force behind that scene is not fiction. Right now, 1300 light years away, it is tearing a real planet apart. We have watched that planet shrink year after year for almost 2 decades. We will come back to it. First, Kip Thorne and the scene he refused to fake. It's the one nobody forgets. A small craft touching down on a planet that's nothing but shallow water, flat to the horizon in every direction. The crew has minutes, and on the edge of that horizon, something is rising. Not a storm, not a swell, a wall of water more than a kilometer tall, moving toward them without a sound. That image is the reason the whole film works, and it's the one Thorne had to fight hardest to keep. This wasn't a consultant waving a script through. Thorne is the physicist who, 3 years after the film came out, won the Nobel Prize for detecting gravitational waves, the actual ripples in space-time Einstein predicted a century earlier. Nolan hired him to make the science hold. And the scene with the wave is where it came closest to breaking. It started as a fight. Nolan's first demand was a ship that could outrun light. Thorne spent weeks walking him through every law of physics that forbids it, until Nolan let it go. Then came the next demand, and on this one, Nolan wouldn't budge. 1 hour on the planet had to cost 7 years back on Earth. Thorne's first instinct was that this was impossible too. A world sitting that deep in a black hole's gravity should be torn apart long before it could ever hold an ocean. He went and did the math anyway, and he found a loophole. One narrow set of conditions where it just barely holds. He put it bluntly later. He couldn't blame anyone for saying it can't be done, unless it was a physicist who should have run the numbers first. But the loophole came at a price. For 1 hour to cost 7 years, Gargantua couldn't just be huge, it had to spin. Almost exactly as fast as a black hole is physically allowed to spin, right at the very edge of the limit. Keep that in mind, it's where the trouble starts. And the core of it is real, that 1 hour for 7 years is just gravity bending time, the way Einstein said it would. We've measured the same effect on Earth with atomic clocks. Your GPS would drift by kilometers a day if we didn't correct for it. The crew goes down for what feels like an afternoon and comes back to 23 years gone. A man who waited on the ship aged into a stranger. That part is real. Which leaves the wave. And the wave is the part most people get completely wrong. When you watch it, the wave looks like it's racing toward the crew, like a tsunami. It isn't. The wave isn't moving at all. The planet is. Miller's planet sits so close to the black hole that it's been stretched into the shape of a football. One end permanently aimed at Gargantua, the water locked into 2 giant fixed mounds that don't travel. The planet rotates underneath them, sliding you into a mountain of water that was standing still the whole time. And if you're wondering why a planet sitting that close isn't simply torn apart, that's the one thing the black hole's enormous size buys you. It's so massive that the pull on your head and the pull on your feet is almost the same, so the stretching stays survivable. So the wave is real, strange but real. The wave was never the problem. The problem is that spin, and that spin is the loophole's fatal flaw. In 1974, Kip Thorne himself published a paper that proved no black hole in nature can reach the edge Gargantua needs. When a black hole feeds off a disk of hot gas, it keeps swallowing photons that push back against its own rotation. That drag sets a ceiling. The number became known as the Thorne limit, a spin of 0.998. A 2009 analysis in the monthly notices of the Royal Astronomical Society reconfirmed the same ceiling. Except in very exotic cases, no naturally grown black hole gets past it. Gargantua needs 0.12 times 9. That's not a little over the line. That's 14 decimal places past his own ceiling. A black hole spinning that close to the maximum is something Thorne, in his technical notes, called very rare or never in the real universe. Listen that back slowly. The man who proved in 1974 that this kind of black hole shouldn't exist is the same man who, 40 years later, built one for a movie. He knew. He wrote down that he knew, and he did it anyway, because Nolan asked for the dilation, and Thorne went hunting for any loophole, however thin, that would let the story stand. For a long time, that calculation lived only in Thorne's book. Then, in June 2026, 3 physicists from India, Harleen Dhingra and her colleagues at the Inter-University Center for Astronomy and Astrophysics, published a full reproduction of the interstellar math in the scientific literature. They confirmed it. A planet really can sit in a stable circular orbit that close to a maximally spinning black hole and experience time dilation this extreme. The physics is internally consistent. It just needs a black hole the universe almost certainly never builds.
So the planet is already balanced on something that probably doesn't exist. And the spin isn't even the part that breaks it. Because let's say you grant him the spin. Say a black hole like Gargantua really is out there somewhere, against all the odds. The planet still can't work. And the reason comes from the exact same dial Thorne turned to make the scene dramatic. That time dilation, the 60,000 to 1. It doesn't just slow your clock, it does something to the light falling on the planet. Think about the cosmic microwave background. It's the faint afterglow of the Big Bang, the oldest light there is, sitting at a gentle 2.7 degrees above absolute zero. Harmless. It's drifting through you right now and you've never felt it. But on Miller's planet, time runs 60,000 times slower than it does out in open space. So all that ancient radiation pouring in from every direction at once gets compressed, squeezed, shifted up the spectrum into something with teeth. In April 2026, 2 physicists, Yuan-Hong Chu and Bing Zhang, did the math on exactly that. Their finding, published in the research notes of the American Astronomical Society, on Miller's planet, that gentle background glow arrives at an effective temperature of around 100,000 degrees. The energy hitting the surface climbs by a factor of 10 to the 19th, a 1 with 19 zeros behind it. The ocean doesn't have time to boil. It ionizes. The water gets torn apart into charged particles. The whole world becomes a sheet of plasma. And this is the part I keep coming back to. The exact thing that makes the scene work, the deep time dilation, is the exact thing that turns the planet into a furnace. The drama and the death come from the same number. You cannot have the 7 years without the plasma. Thorne picked the most extreme dilation he could reach to give the film its gut punch, and that one choice quietly cooked the world it was set on. So Miller's planet, the water world, was never going to be a water world at all. There's a quieter consequence of the same effect, and almost nobody mentions it. We've been talking about light pouring onto the planet, but what about light leaving it? Anything trying to climb back out of that gravity well loses energy on the way. Visible light, the kind you'd see by, gets stretched and dragged down the spectrum. By the time it reaches open space, it's degraded into faint radio waves. So a planet that is being scorched from the outside would look almost invisible, burning from within, dark from without, both at once. Which leaves you with a question that sounds almost unfair. If the planet can't exist and the black hole can't exist, then why does any of this feel so real? Because the force underneath it is real. And it's doing its work right now, on a planet we can actually point a telescope at. This is the planet I told you we'd come back to. Its name is WASP-12b, a gas giant about 1.5 times the mass of Jupiter, sitting roughly 1,300 light-years away in the constellation Auriga. It was found in 2008, and it's dying. WASP-12b orbits its star in 26 hours. Not 26 days, hours. It's so close that the star's gravity has stopped treating it like a sphere. In 2024, the CHEOPS Space Telescope, working with TESS and older Spitzer data, confirmed the planet has been stretched into the shape of an egg, pulled out along 3 separate axes at once by tidal forces. The same kind of tidal stretching Thorne described for Miller's planet, except here it isn't a note in a book, it's a measurement with an error bar. And the planet is losing. Every year its orbit shrinks. We've watched it happen across 17 straight years of observation. 3 independent teams landing on the same number. The orbit is tightening by about 30 milliseconds a year. The first hint came from Kishore Patra at MIT in 2017, but the data back then couldn't rule out a gentler explanation. In 2020, a team confirmed the death spiral with odds of 70,000 to 1. WASP-12b is corkscrewing into its star, and the math gives it somewhere around 3 million years before it's torn apart and swallowed. 3 million years sounds like forever. For a planet, it's the final breath. To put it in scale, 3 million years ago, our ancestors hadn't made the first stone tools yet. On the clock of an entire world, WASP-12b is in the last fraction of 1% of its life. We didn't catch it young. We caught it at the end. We are, right now, watching a planet die in real time, taken apart by the exact force Christopher Nolan put on a movie screen. And it's leaking. The star's pull is dragging the planet's upper atmosphere off into a long, glowing stream of gas, falling toward the star like water circling a drain. That is the closest thing to Miller's planet that actually exists. Not a calm ocean in a comfortable habitable zone, a giant being slowly dismantled by the thing it orbits. Now, the detail that changes how you read the whole scene. The gargantua you see in the film can't even produce the scene you just watched. Paul Franklin was the visual effects supervisor on Interstellar. His team built the black hole, frame by frame, on a renderer so advanced it generated 2 real scientific papers along the way. And in early 2025, replying to a science video in a public comment, he admitted something the marketing never mentioned. To make Gargantua look the way they wanted, clean, symmetrical, that perfect glowing ring, they quietly turned the spin down, from near the maximum all the way down to 0.75, for looks. His words. They preferred the more classic circular shadow for aesthetic reasons. But a black hole spinning at 0.75 can't bend time by 60,000 to 1. It comes nowhere close. So the version of Gargantua on the screen physically cannot create the time dilation the entire plot depends on. The film shows you one black hole and tells you the story of a completely different one. A truthful Gargantua would actually look stranger, lopsided, one side blazing blue where it whips toward you, the other dragged dark and red where it spins away. The clean, balanced ring they chose was the lie. The ugly one would have been the truth. And Miller's planet isn't even the only real world that proves the larger point. Because nature builds planets in places that should be impossible. In January 1992, a Polish astronomer named Alexander Wolszczan found the first planets ever confirmed outside our solar system. Not around the sun, around the pulsar. The burnt-out, spinning corpse of a star that had already exploded. The system is nicknamed Lich, after the undead king of fantasy stories, and its planets carry the names Draugr, Poltergeist, and Phobiter. Every one of them sits in a storm of radiation that sweeps across them 160 times a second, like a cosmic lighthouse made of X-rays. Nothing we'd call life could survive there. And yet the planets are there, stable, real, found by accident while Wolszczan was using a damaged telescope doing repairs. That's the thing the film was reaching for without quite saying it. Planets don't only exist in the gentle places. They exist in the hellscapes too, hanging on in conditions that should tear them apart. And there's one last consequence the film never says out loud. It's quiet, and it's the saddest part. When the crew arrives, they're chasing a signal from Dr. Miller, the scientist who landed there years before. To them, she's been broadcasting for over 2 decades, a steady beacon, the whole reason they came. But because of the time dilation, those 23 years of signal stretched across all that distant time, on her planet amounted to about 4 hours. She didn't last long down there. She died minutes before the crew touched down, killed by one of those standing walls of water as the planet turned her into it. The beacon kept transmitting because her clock had barely moved, which means the mission that was supposed to save the species, the choice to burn years and fuel descending to that world, was made on the strength of roughly 4 hours of real data. They thought they were following a survivor. They were following an echo.
So, Kip Thorne built a planet at the very edge of what physics will permit. A black hole spinning faster than the universe seems to allow. An ocean the same physics would flash into plasma. A scene the filmmakers couldn't even bring themselves to draw honestly. He wrote in his own notes that it probably doesn't exist. He was right. It doesn't. But the force that would tear it apart is out there, 1,300 light years away, doing it to a real world right now. We didn't have to imagine it. We just had to look. So guys, I hope you liked that I did the voiceover myself this time. Thanks for watching. There is a video on your screen the algorithm thinks you also would like.